Lesson 3.4 Part 2. Yesterday we operated within scientific notation using multiplication and division. If you recall, with multiplication we multiplied the first factors and then multiplied the powers of 10 and then made sure our answer was in scientific notation. And then for division we did the same thing. We divided the first factors and divided with the powers of 10 and made sure our answer was in scientific notation. Right here I wrote this little, I put this part in here for you as a reminder. A number written in scientific notation has one factor greater than or equal to 1 and less than 10, and the other factor is a power of 10. So that first number can be 1 or greater, but it can't be any bigger than 9.99999. Here we have the mass of the moon is about 7.35 times 10 to the 27 kilograms. Find the combined mass of Earth and the moon. So when we combine it, we're going to go ahead and add them. Oops. So we have 5.97 times 10 to the 24th plus, and I'm going to write it underneath each other here, 7.35 times 10 to the 22nd. Well, it doesn't work so that you can just add the first factors and add the powers of 10 here. What we have to do first is get the same power of 10. We must do that first. So I can either make this 10 to the 22nd or I can make this 10 to the 24th. It doesn't really matter, but you have to do one or the other. So what I'm going to end up doing is I'm going to make the 10 to the 24th equal to the 10 to the 22nd. So if I want to change this power of 24 and I want it to come down by 2, that's making this smaller. Come on now. So I have to make this number larger by a power of 2. So let's go ahead and take it down here. If I make this larger by a power of 2, I move the decimal 2 to the right to make it bigger, so it's 597 times 10 to the 22nd. So again, I compensated, made the exponent, the power smaller, made the first factor larger. And then I have 7.35 times 10 to the 22nd also. So now I go ahead and add these numbers together. 597 plus 7.35 is going to give me 597 plus 7.35, 604.35, and then I keep this as times 10 to the 22nd. Now it says write your answer in scientific notation. This is not in scientific notation because look, this first factor is clearly bigger than 9.99. So I have to move the decimal over and it becomes 6.0435 times 10. I made the first factor smaller, so I need to now make my exponent larger. And I moved it twice, so I have to bump this up twice. So it's 6.0435 times 10 to the 24 kilograms larger. Not larger, I'm sorry, combined. We were combining the mass of the Earth and the moon. If I wanted to know how much larger, then I'm going to have to subtract. Okay, so now let's go ahead and go on to subtraction. How much greater is the mass of Neptune than the mass of Venus? So Neptune is bigger. I'll go 1.02 times 10 to the 26th, subtract Venus, which is 4.8, oh my goodness, come on now. 4.87 times 10 to the 24th. So I will go ahead on here and I'm going to change that 26 to a 24. And to do that, I have to subtract 2 from here. So that means I'm making this 2 smaller, and I will make this first factor 2 larger. So it's 102 times 10 to the 24th, subtract 4.87 times 10 to the 24th. And I'll go ahead and subtract 102, subtract 4.87 is 97.13, times, I keep it 10 to the 24th. Again, this is not in scientific notation, and they're asking me to write it in scientific notation, so the decimal has to go 1 to the left, so that's 9.713 times 10. I made this number smaller by a power of 10, so this number needs to bump up. So it's 10 to the 25th. And this is in kilograms. So in this case, Neptune is 9.713 times 10 to the 25th kilograms larger than Venus. Let's do a couple more of these. Between 2008 and 2009, Americans spent $8.48 times 10 to the 8th on baby food. During the same period, Americans spent 4.52 times 10 to the 9th dollars on ice cream. So we like our ice cream. How much did Americans spend altogether on ice cream and baby food? So altogether means we're going to go ahead and add. So 8.48 times 10 to the 8th plus 4.52 times 10 to the 9th. It doesn't really matter which one of these that I change, so I'm going to go ahead and change this one because it's on top. I'll change that to the power of 9, which means it's going to be times 10 to the 9th. I increase this by a power of 10, so I need to make this number decrease by a power of 10. So 0.848 plus 4.52, and these are both times 10 to the 9th. So I'll add the first factors, 0.848 plus 4.52, and I get 5.368 times 10 to the 9th. And this would be dollars. If I rounded this, it'd be about 5.37, because I'm looking at dollars and cents, times 10 to the 9th. It's not a negative, it's just my pen is going crazy. Okay, and that's how much money we spent. So that would be, if we think about this, I would move the decimal 9 places over, because it doesn't say write it in scientific notation. So let's look. There's 2 places, so 1, 2, and then 7 zeros. 1, 2, 3, 4, 5, 6, 7. Put in my commas. That is a lot of money that we spent on baby food and ice cream. Let's see, there's millions, billions, $5,370,000,000 on baby food and ice cream between 2008 and 2009. Lots of money. All right, and lastly, approximately 3.28 times 10 to the 6th cubic yards of material were used to build Boulder Dam on the Arizona-Nevada border. The new Cornelia Tailings Dam in Arizona used 2.74 times 10 to the 8th cubic yards of material. How many more cubic yards of material were used to build the Cornelia Tailings Dam than the Boulder Dam? So we put the larger one on top, which was the Cornelia Tailings, and then the Boulder Dam, and we are subtracting. We want to know how much more material. So I'm going to go ahead and make this to the power of 6. I'm making this 2 powers of 10 smaller, so it's times 10 to the 6th, which means I need to make this 2 powers of 10 larger, so 274 times 10 to the 6th, subtract 3.25 times 10 to the 6th. So 2.74 subtract 274, I said it wrong, subtract 3.25 is 270.